This video is going to help us understand the different types of distributions that we see that are very typical throughout the rest of the course. We're going to look at it from two different views, the histogram and the box plots, and see what this implies about the data set. Please try to take as good notes because you can use them on your assignments and probably be able to use them on your test. The prior learning that we're going to match this up with is that you've already tried to make histograms and box and whisker plots in the Delta Math program. When you look at a histogram, there are 5 or 6 types of distributions that we want you to be very familiar with. The first type is the symmetrical distribution. You should be able to recognize a symmetrical distribution because what we want you to look for is a histogram that is approximately the same on the right side and left side of the graph. So if I take a vertical line and place it here in the middle, notice that on the left side of this graph, it's approximately the same shape as the right side of the graph. Please don't think that it has to be perfectly symmetrical. I made this one just a little bit shorter. There are 2 types of symmetrical graphs that we want you to be more specific on. These 2 kinds here. This one, if it kind of grows up to a peak and then decreases back down on the right-hand side, that is a symmetrical graph, but we would like you to use a more specific name called the mound-shaped graph or normal. I'm going to highlight the word normal here for us. So if you see this kind of graph, you're going to start getting the idea that we're going to refer to it as a normal graph or normal distribution. This one is also symmetrical. It is the same on the left side and the right side, but there's an even more specific name we're going to want you to use. The more specific name can be either called rectangular or uniform, depending on which resource you use. The next type of graph that we would like for you to understand is the skewed graph. Skewed graphs can go either side. Be careful though, this one that has the tail on the right-hand side of the graph is called skewed right. And the eyes are carried towards the bigger bars over here, but this is correct. This one is called a skewed right graph because it refers to how the median and the mean compare to each other. The mean is going to be pulled to the right, which then that makes this graph with the tail on the left side called a skewed left graph. And again, it's because the median would be somewhere here, but these data values are pulling the mean down or towards the left side of the graph. And we also would like for you to be able to recognize these types of graphs. This one happens to have 2 pretty distinct peaks. When it has 2 distinct peaks, we want you to label that kind of graph as bimodal, 2 different modes to the data set. And the final one is the one that doesn't fit into any of the prior other categories. We want you to consider that as a random distribution because it's very chaotic. It's just kind of all over the place. There's not really 2 peaks. There's not numbers pulling it to the right side or the left side. And it's definitely not the same if I split it down the middle on the left and the right side. Now let's take a look at what these look like when you see a box and whisker plot. A symmetrical box and whisker plot will look similar to this picture on the right-hand side. The median line should be close to the middle of the box part of your plot. And the whiskers are approximately the same length on the left side and the right side. And again, they don't have to be exact, but if its line is pretty much in the middle and approximately same here on both sides, we're going to call it symmetrical. You can also have a graph, a box plot graph that is skewed to the right. That's similar to the picture here. And what I want you to notice is 2 different things. The whisker on the right side is longer, and the bar in the middle, the median bar, gravitates a little bit more towards the left side of your graph. If you see those 2 things, we want you to call it skewed right. And then let's reverse that. So if you see a longer whisker on the left side of the graph, but the median bar in the box is gravitating over towards the right side, we want you to call that skewed left. Feel free to pause the video if you need more time to write. All right, let's compare them side by side. These two graphs are both symmetrical. If you split it down the middle, approximately the same on left and right. The bar in the middle, approximately same length on the whiskers. What does that imply about your data set? If you see a symmetrical type of distribution, it'll imply the median value and the mean value of your data are close to the same number. If you see actually, I'm kind of hoping to pause here and ask you, do you know what kinds of graphs these are? And I'm hoping that you chose skewed left. So let's get used to the idea that in a histogram, if the tail's on the left, or in a box and whisker, the whisker is longer on the left. If you do see a skewed left distribution, what that tells you about the numbers is that the mean is on the left side or lower than the median. The mean is lower than the median. And then the last one that I want to compare side by side is the histogram that has the tail on the right side, or a box plot that has a longer whisker on the right side. Those are called skewed right. And a skewed right graph implies that the mean will be to the right of, so higher than the median. Mean is to the right or higher than the median if your graph is skewed right. All right, in summary, the symmetrical graphs will imply that you have about the same amount of information or data points on the left side as you do on the right side, and the mean and median will be close to the same number. A skewed left graph means the tail is on the left side of the histogram, or the whisker in your box plot is longer on the left side. The mean will be lower than the median. And in a skewed right graph, the tail on the right side of the histogram is longer, and the whisker is longer on the right side if you look at a box plot. And that implies that the mean will be higher than or to the right of the median.